Next up, let's focus on version control and collaboration tools. In collaborative AI development, effective version control and communication are essential. Git allows for efficient tracking of code changes and project management tasks, while platforms like GitHub and GitLab enables seamless collaboration between teams. Additionally, Jupyter notebooks offer an interactive environment for data exploration, model experimentation, and sharing results in user-friendly format. First, let's talk about Git. Git is a distributed version control system used by developers to track changes in their code and collaborate with others. The key features of Git, the first one is branching and merging. Git allows easy branching and merging capabilities, making it great for collaboration. Next, we have distributed. Distributed, everyone, which enable Git enables everyone to has a copy of the entire repository, making it easier to work offline. The use cases of Git, it's used in tracking code versions and collaboration between teams. The next tool we have here is GitHub and GitLab. GitHub and GitLab are platforms built on top of Git, enabling easy code sharing, collaboration, and version control. The key features of GitHub and GitLab are providing users the ability to create pull requests, which is a way to review and merge changes. CI and CD integrations, both platforms support continuous integration and continuous deployment pipelines. The use cases of GitHub and GitLab, which is used in code hosting, collaboration, and an open source project. About Jupyter Notebook. Jupyter Notebook is a web application that allows users to create and share documents that contain live code, quotations, visualization, and narrative texts. The key features of Jupyter Notebook, it provides an interactive development, which is useful for data analysis and experimenting with AI models. The next feature that Jupyter Notebook provides is visualization capabilities with integration with its libraries like Matplotlib and Seaborn for plotting. The use cases of Jupyter Notebooks, it's used for data exploration, AI model prototyping, and education as well. On to our next topic of discussion, we are going to talk about data annotation tools. As you know, that data is the cornerstone of AI, and accurate data annotation is critical for training reliable models. Tools like Labelbox, SuperAnnotate, and V7 Labs provide solutions for annotating large datasets, particularly for image and video analysis. These platforms streamline the labeling processes, enabling teams to create high quality training data that directly improves the model accuracy and performance. On our first tool, we're going to discuss about Labelbox. Labelbox is a data labeling platform used for training AI models with label data. The key features of Labelbox are collaborative platform which allow teams to collaborate on labeling tasks. Also, it provides an AI assistant labeling capabilities which use AI to pre-label data which can then be manually corrected. The use cases of Labelbox, it's used widely in image annotation for computer vision tasks and video data labeling for action recognition. Next, we have SuperAnnotate. SuperAnnotate is a platform for creating and managing labeled datasets for training AI models. The key feature are providing AI power tools as well as pre-trained models to help with labeling tasks. Also, it provides a well-known version control which track all of the annotation to ensure the consistency. The use cases of SuperAnnotate, it's used for AI models in autonomous driving, facial recognition, and medical image analysis. The next tool that we're going to discuss about is V7 Labs. V7 Labs is an AI platform for computer vision tasks, offering tools for data labeling and model deployment. The key features of V7 Labs providing an AI assisted annotation which helps auto label images and videos, speeding up the data preparation. It also provides custom models, pre-trained models for tasks like object detection and segmentation and customizable for specific needs. The use cases of V7 Labs, it's used widely in medical imaging, automating the annotation of medical scans for disease detection, for example. Also, it's used in retail analytics by analyzing customer behavior in stores to optimize the layout and inventory. Now let's take a look about AI model deployment and monitoring tools. Deploying and maintaining AI models in production requires specialized tools to ensure the scalability, security, and continuous performance. Tools like TensorFlow, Serving, and Dockers, and Kubernetes, and ML flows helps developers to deploy models efficiently and scale them in real-time production environments. Additionally, platforms like MLflow ensures that the entire machine learning lifecycle from model development to deployment is well managed and consistent. The first tool here we have is TensorFlow Serving. TensorFlow Serving is a library that helps in deploying machine learning models in production. The key features of TensorFlow Serving, which provide real-time inference, which is optimized for low latency predictions. Also the scalability, which can serve model at scale. The use cases of TensorFlow Serving, it's used in real-time image recognition in production environments. Docker. Docker is a tool that allows you to package your application, including the operating system, libraries, and dependencies, into a container. The key feature of Docker, the key features of Docker are the isolation capabilities when running application in isolated environment to avoid conflicts. Also, the portability, ensuring that the application runs the same on any machine. The use cases of Docker, it's used in packaging machine learning models and deploying them across different environments. Next, we have Kubernetes. Kubernetes is a system that is used for automating the deployment, scaling, and management of containerized applications. The key features are the scalability, providing easy scale AI application horizontally. Also, self-healing. Self-healing is the ability to automatically replace failed containers. The use cases of Kubernetes when managing and scaling AI workloads in cloud environment. Lastly, we have MLflow. MLflow is an open source platform for managing the end-to-end machine learning lifecycle, including experimentation, model tracking, and deployment. The key feature of MLflow, it provides an experiment tracking. It records and compares multiple machine learning experiments to identify the best performing model. Model Also the model management, which provide tools for versioning, packaging, and deploying models across different environments. The use cases of MLflow, it's used in model experimentation, like tracking and comparing machine learning models with its results to optimize the performance. as well as in model deployment when managing and deploying machine learning models in production environment for consistent results. Moving forward, let's talk now about the automation and orchestration tools. As AI models grow in complexity, automating workflows become essential. Apache Airflows and Kubeflow and MLOps enable developers to design, automate, and monitor end-to-end machine learning pipelines. These orchestration tools allow for streamlined data processing and model training and deployment, ensuring that AI applications run smoothly at scale. The most common tools used on automation, which is Apache Airflow. Apache Airflow is an open source platform to programmatically schedule and monitor workflows. The key feature of Apache Airflow, it enables the task scheduling, allowing setting dependencies between tasks. Also monitoring. Monitoring provide by providing the users a user interface to track the status of the workflows. The use cases of Apache Airflow, it's used in automating AI pipelines such as data collection workflows, model training schedules as well. Next we have Kubeflow. Kubeflow is a machine learning toolkit for Kubernetes, enabling the deployment, monitoring, and management of machine learning models. The key features of Kubeflow, the first one is integration, enabling seamlessly integrate with Kubernetes for model deployment. Also, to provide end-to-end pipeline when supporting the entire machine learning lifecycle from training to deployment. The uses of Kubeflow, it's used at building scalable AI pipelines and production. Last one we have today is MLOps. MLOps is a set of practices that combine machine learning and DevOps to automate and streamline the deployment and monitoring and management of machine learning models in production. The key features provided by MLOps provide the model deployment capabilities by automating the deployment of machine learning models to production environment. Also, continuous integration and continuous delivery, CI and CD, ensuring the seamless updates and testing and monitoring of models. The use cases of MLOps, it's used in model monitoring to ensure continuously monitoring the models in production to detect performance drift and trigger any issues. Next use case we have here is automated machine learning pipelines. By providing the capabilities to automate the entire machine learning lifecycle from data pre-processing to the model deployment. Our last topic for today's session is AI model evaluation and testing. Ensuring that AI model meet the performance benchmarks is critical before deployment. MLPerf, TensorBoard, and WandB tools are essential tools for tracking, visualizing, and optimizing model performance. These tools allow developers to evaluate metrics like accuracy and efficiency, loss, helping to fine-tune models for better results and continuous improvement through the machine learning development life cycle. The first tool we have today is MLPerf. MLPerf is a benchmark for measuring AI model performance across a variety of tasks. The key features that MLPerf provide an industry standards by providing objective metrics for comparing different AI models. Also, to provide a diverse benchmark, including benchmark for deep learning models and reinforcement learning and recommendation system models. The use cases of MLPerf, it's used to evaluate AI model efficiency and performance across different industries. Next tool we have is TensorBoard. TensorBoard is a visualization tool for TensorFlow that helps track and visualize machine learning experiments. Two main key features here is tracking. By visualizing metrics like loss, accuracy during the training process. Also to provide graph visualization capabilities to visualize the computational graph of your model. The major use cases for TensorBoard, it's used for debugging models and tracking experiment results. Next, we have WandB, which is weights and biases. It's a platform for tracking and visualizing machine learning experiments. The key features that been provided by WandB tool is to provide an experiment tracking like logs, metrics, and code versions and hyperparameters. Also to provide collaboration by allowing teams to share their results and collaborate together. The most famous use cases are the experiment tracking, team collaboration, and model development. In conclusion, the integration of these tools and framework play a critical role in the AI development lifecycle, from selecting the right programming language and framework to leveraging cloud platforms to enable the scalability of your AI solution. Also, the version control for collaboration to ensure that data is properly annotated and models are deployed efficiently. Each component of these serves to enhance the development processes, also providing automation tools to streamline your workflows. The evaluation tools to ensure that the model perform at their best. Together, these technologies and tools and frameworks empower AI professionals to create scalable and innovative and high performance AI solutions that can drive change across different businesses and different industries.